Welcome again to the Computer Science Lab. We are now on session 6 of MSc Computer Science project, the final project, which corresponds to the actually phase 6 of your project. Testing, experimentation, getting results, improving results. So it is the bulk of your primary research work. The objectives of this session: we need to explain the testing and experimentation phase of your primary work, and then the implemented system that needs to run to get these results. For example, if it is an algorithm or protocol or method, model, system, whatever it is, it needs to run to test and get results. Without running it, then you can't get results. There is nothing to evaluate. So then after that, then you will try to improve those results. So what have you done with it? It's not just about getting some results and then display them and then just show that, yeah, I have done this. No, it is about improving them and then analyzing them and evaluate it. Without doing this type of work, there is nothing to analyze and evaluate. And we cannot emphasize this enough here, that they must be your results. Do not get influenced by the results of other people. Hopefully, at this session, you will know what is expected from you at this stage of the project. So again, progress so far. What have you done? What have you achieved so far? So you have implemented the system, as we explained in the previous session. And now it is time to get some results. For machine and or deep learning projects, so you run the algorithm to detect or predict something and then get your initial results. It doesn't matter how low they are or they look bad. It doesn't matter, because you have the time in front of you to improve them and get better results. For a pen testing project, then you conduct the pen test to get vulnerabilities, to do the exploits for each methodology or tool that you have decided to use as part of the project. For a networking project, let's say you have a network protocol to evaluate, you test it, experiment with it in order to get results. Or for an encryption protocol and method, you run the encryption, you test it, and you want to see its strength. And for a software engineering project, for example, this is another example. Yeah? So you are evaluating a game engine, you run the implemented game to get results in order to evaluate the engine efficiency. So time to test. Again, as we said, we cannot emphasize this enough. Your mindset is very, very important, extremely important, because you have to put yourself in some type of shoes, that you are a professional, you are doing the work for an imaginary client, and then what does this client want from you? So they want your results. That's why you have to ensure that your results are yours. It does not matter if you are not achieving 99% accuracy or efficiency or effectiveness. As you can see here, we are not impressed by figures of 99%, 100%, 99.99999%. No. Most probably they are not real, because the projects that you have read, that you have done your research, and you have seen that maybe they have some excellent results. Those projects are well funded. They may have had more time, much more time than you. They have had much more resources. So you can't compete with them. You just need to be honest about your authentic figures. So the most important thing here is what you see in the second bullet point. It is to have complete knowledge of the system that you have built. That's most important, because then you can explain even the results that you have achieved. So a certain project has achieved 95% accuracy. Your accuracy is 75%. or you have done your best and maximum you can get is 80. Doesn't matter. Even with 80%, you can get excellent grades if your results are authentic and you know what you have done. And we are more interested to see the journey that you have gone through, the improvement journey. For example, that from the beginning you got like 45% efficiency, accuracy, or whatever the results came up with, and then you improve them. You can see here, for example, for a machine learning algorithm project, the journey from 45 to 75% is a 30% improvement. If you show how you have made that improvement, what you had to tweak, what you had to change in the algorithm or in the way that the algorithm processes the data set. If you show the changes that you have made and how you got that 75%, the authentic one, then you can get excellent marks. So this has to be your own primary work. Look at this diagram here. We're going to make it bigger here so then we can see it better. And this is to visualize the work that you are doing now. The end result is the evaluation. That is what you want to do. You want to evaluate, so then you can go back to the client or to the imaginary sponsor and then give them some recommendation. You can't give them recommendations unless you draw your own conclusions and then you evaluate everything and then you have some recommendations to make for that imaginary client or sponsor. So that's why, so you see the word customer there, and then on the right hand side you see the methodology that you are doing, testing, test procedures, okay, algorithms, everything here. You have the results, the test data, and you have that imaginary customer or client there that you collaborate with. Obviously, for this MSc project, you don't have a sponsor, you don't have a client, but you have to keep it in your mind that you have one. That's the mindset. And then you will be able to do an excellent job. So, we are testing now the algorithm. What is the mistake that students make? Students try to copy everything without understanding. So then you have to understand everything from the top level first. What is the job in just simple terms? It is you have a data set to use for the testing and learning. Okay, divide the data set. How do I divide it? What is the ratio? It is 75 for testing, 25 for 75 for learning, 25 for testing. Okay, why that? Or 80-20 or 70-30? You have made that decision based on your literature review, based on the secondary research that you have done, because that is the best way to test this with the data set. Okay, divide. And then you do the learning process, the testing, you get results. So in this case, here in this diagram, we are showing an implementation of a project that is about malware detection. So then you run the training phase. The training phase may achieve excellent results. And then you have the testing phase, the detection phase, that puts the malware tag as it will be in real life. So you see now the actual work that you have done visualized in a flow chart. How your work, this is the flow chart of your work, how your work will run. And obviously you have a data set. So then the question is how to use this data set. If you understand it from the top level point of view, that what you need to do and then why you are doing what you're doing, then you'll be able to look at the data set, how to pre-process it, how to take things off that are not needed about this here, because you know how the algorithm will make the decision. And then we'll ask questions to you, for example, that, okay, why is this field in the dataset important? How is it used by the algorithm to make a decision? So again, it is about this here, to generate this. Benign program, malware. Okay? Good program, bad program. Clean program, infected program. It is a binary decision. So that is why you see here that the results in the detection project will be binary. Yes, no. Good, bad. Malware, clean. So that is the attack recognition here. Either the traffic is good traffic or it is bad traffic, part of an attack. That is how the system will work. The reason why this is explained here is that we want to show in your demonstration, or you need to show us in your demonstration, how this works. Even with the data set is there to train and test it, but then you need to demonstrate how this will work in real life, because in real life it will work with just one thing at a time, one application at a time, one decision at a time. It will. So you have to show that how can you input now only one element of the data set? Because look, it is very important to understand the stages of this. So how are you going to improve this? How are you going to improve the results? So then you're going to take from the confusion matrix one element of the data set, one record of the data set that you know that that program is clean, and the system takes it and considers that it is infected, and you know that it is clean. So how does the algorithm make the decision that for a clean program to show that it is infected? Okay? Confused algorithm. Or worse, that it is an infected program, it has got malware, and you know that it has got malware, and the program makes the decision that it is clean, okay? Your algorithm, which is worse, because then the false negatives is the one that you want to reduce. So in this case, the improving experiment is about reducing the false negatives. How are you going to do that? So then you can show to us in the demonstration that, look, this program here is infected. We know it is infected. We input into the algorithm says it clean. Why does it make that decision? And then you can show us how it makes the decision and what you have done about it. That's very important, okay, about improvements. And what are the mistakes that can be made at this stage here? Thinking that some results will do. So student implements something, they put the data set there, and then, yeah, that's my results. And then, yeah, but what have you done with them? Because just some results will not do. It is about the confusion matrix that you will use as part of your improvement project. So now you know that what is expected from you during the demonstration phase, that you need to show how the algorithm works, or how it will work in real life. In real life, will work at one program at a time. It is input. The algorithm takes one program, considers it, and makes a decision. Good, bad, infected, clean. You have to show that with one element, and show us what you have done in order to improve that. What is the point of all this work? Again, don't lose focus of the last stage of your project, the evaluation, because we need to evaluate something. It can be the accuracy, it can be the efficiency, effectiveness, or strength, or precision. And apart from the validity of the experiments, we need to evaluate even actually our own work, implementation work, how we have implemented it. And again, must not forget the goal, the purpose of the project, to give recommendations about how good the system is. It's not about that just it works. You can see now the diagram here, the 5 stages of the experimentation work here, and try to interpret that, so how you can use it in your own project. Summary, we have results. And there should be no expectations that the system you have built is 100% good. We don't have that. You shouldn't have that expectation. So the job is not about certifying that the system is good or the algorithm is perfect. No, you may actually come to a decision that this algorithm is not suitable for this purpose. And then your recommendation may be not to use this algorithm for this purpose because according to the project that I have run, this algorithm is not good. And this is backed up also by other authors because I have done some research during literature review. I found out that this author, they have achieved the same type of results as mine. So they are comparable. So it doesn't have to be about, oh, I have to do this at any cost to prove that this algorithm is excellent. No, it can be whatever it is, whatever your results show. So now you're ready to carry out your analysis and evaluation. So see you at the next session about analysis and evaluation of results.